We have implemented all the basic logic gates earlier. Now we'll move to the next part of lab 4, which is proving Demorgans law using Quartus. I'll copy the code, Control C, and then here just go here, Control V, and everything seems alright. Yes, I'll go through the quick explanation of this code. Here we have declared the start as we have written module, then we have named this part. I'll just change this to that, and then here we have two inputs, A and B, and in De Morgan's law we have two equations. Now each equation has a left hand side and right hand side, so I have formed equation for each side. So in total these are 4 equations, which is left hand side of first equation, then right hand side of first equation, then left hand side of second equation, then right hand side of second equation. Now here we have declared the inputs, then outputs, then at outputs, for each output we have assigned them the value we wanted to according to the De Morgan's law. This is left hand side of first equation, right hand side of first equation, left hand side of second equation, and right hand side of second equation. And now we will proceed simply to compilation of this code. And yes, okay, as we can see, our compilation was successful and there were 0 errors. So we'll just proceed to RTL view, locate in RTL view. Now here we can see the diagrammatic representation of De Morgan's law. These are the names as I had selected: left hand side of first equation, right hand side of first equation, left hand side of second equation, and right hand side of second equation. Nothing is clear yet. We'll see the results in the waveform whether they verify De Morgan's law. And here we'll just click new and university program BWF, okay, and then we'll left click, insert node finder, list, move all, okay, and okay again, and we'll move our inputs to top, positioning left hand side and right hand side of equation 1 together, and left hand side and right hand side of equation 2 together. And now it's okay. Now we will assign our input values a clock. Now for A I'll set it to 50, for B I'll set it to 100. Now we'll simply run this simulation, and yes, okay, set waveform. Yep, done. Okay, now here we can see that left hand side of De Morgan's law first equation is equal to right hand side of De Morgan's law first equation. These were the circuits I formed: left hand side of first equation and right hand side of first equation. Both these waves are same. And then left hand side of second equation is equal to the right hand side of second equation, as both these waves are also same. Hence we can say that De Morgan's law is proved using this software, the Quartus view of this whole thing. That's all for this part. Now we'll proceed to the next part.